Okay, so by my watch, it's 1 minute past, so we'll get started. So first of all, welcome everybody. Good afternoon. For those of you for whom it's afternoon, welcome to our second webinar. In this one, we're going to be introducing you to Silico 2.0, which is the culmination of a lot of hard work by the products and engineering team at Silico, and also wouldn't be possible without the enthusiasm and the feedback from our customers and partners as well. So to take you through the webinar today, it's going to be hosted by myself. For those of you that don't know me, I'm John Hill. I'm founder and CEO of Silico. And I will be joined on the webinar, and driving the demos is going to be Martin Luco, who works in the customer success team at Silico. Very quick agenda. So I'm conscious that some people joining the webinar today might not be familiar with process simulation. So I'm just going to start with a little bit of scene setting, talk about why you might want to simulate processes. They're going to set out my definition of what a process simulation capability looks like, what a piece of software that does process simulation first class looks like and does. We'll then recap a little bit of Silico 1.0, so what the product has been to date, what the functionality and capability has been, the baseline on which we're building. That will be the first demo. I'll then launch into a quick overview of what's new in this release, what's new in Silico 2.0. And Martin is going to drive us through 3 features in particular that we're going to dig deep into, that we're really excited to share with you. And then I'll conclude the webinar with a very brief look ahead to Silico 3.0, just touching on some of the major themes that we're starting to work on right now and that we're hearing from customers and partners are interesting things to explore next. So just very quickly, just to set the scene for those of you maybe who are coming to this new, you know, what we see, the way we see the world at Silico is that there's a problem out there. There's a problem in business processes. There's a problem in, you know, achieving operational efficiency, which is that it's fundamentally very difficult to measure the impact of process change on business outcomes. So there's been a lot of work done in this sort of process discovery layer towards the bottom of my slide. Lots of organizations have invested very heavily in mapping processes, in mining processes, perhaps more recently in doing task mining as well. Every organization has also got at their disposal a bunch of different options for how they want to change, or how they might want to change processes. They can pull levers around people, internal resourcing, offshoring, outsourcing. There are things they can do to transform digitally or change technology that processes run through. And there are also things out there around automation. There's lots of automation going on as well. So obviously there's been a huge wave of RPA over the last decade or so. And the challenge really is how to leverage all of that process discovery to figure out what the change or combination of changes are that drive the best outcomes. And this is what we call the intelligence gap. And process simulation bridges that gap fundamentally. So what this is all about, it's about sitting on top of that process discovery that's already been done, being able to turn that process discovery output into the input to a digital twin of a process, to be able to run process simulations, and then to be able to try out virtually all of those process change ideas you have around automation, digital transformation, and resourcing as well in the simulation, to work out which combination of those changes is going to drive the best outcome for the business. And that's fundamentally what process simulation is all about. So just a very brief bit of history, because, you know, some of the people listening won't be familiar with the history of Silico, the history of the company. Silico was founded in late 2019 by myself and Chris Spencer. We are both, you know, simulation pointy heads. We're from the world of computational simulation, from way back when, and not originally from the world of business processes. You know, version 0 of Silico was all about trying to build a very easy to use, very flexible, no-code simulation framework. And our journey along the way, starting to work with enterprises and discovering really what the applications of the technology were, led us into, and our customers pulled us into business processes. So fast forward to probably summer 2022, it was starting to become clear to us that actually what we were building had real valuable applications in business processes. And that was a real sort of inflection point for us as a company and in terms of our product strategy, and starting to really align around this vision for building a first-class platform for simulating business processes. It takes you all the way through sort of version 1 of Silico and then up to today. And obviously what we'll share with you on this webinar today is where that's got us to, where we're heading next, what 2.0 looks like, and a little look ahead into what's coming down the track. So, I think an interesting question to ask is what should a process simulation platform be able to do? So we now know kind of what process simulation is conceptually, but what does that mean technologically? Well, what we want to have is we want to have a digital twin of a process. That's the objective. And to be useful, that should accurately reflect the structure and the dynamics. So how things change through time, the dynamics of a real world business process. If we have an accurate digital twin of a process, we can use that to guide our decision making and help us think about the best way to intervene and change things in the real world. And I've kind of put on the slide 2 big buckets of things that the sort of the use cases that we're seeing for process simulation that our customers are leveraging the platform for. So there's a big bucket of things around what I call monitoring and controlling processes. So maybe more tactical operational decisions made on a business process. So here we're going to need to have a digital twin of the process that's going to be continuously refreshed. So we've got, it's updated for the latest state of the organization. We want to be using that to simulate forward in time to identify process issues which are appearing in the future. So not necessarily issues which are here today, but issues which might be coming down the track. So we might be able to spot, as we're putting more case volume through a process, we might be able to spot bottlenecks appearing in the future. We might spot that we're going to breach SLAs at some point in the future. We might be able to think preemptively about some resource planning, about how many people we might need and when we need to hire them by. And then there's this sort of second big bucket of things which people are using process simulation for, which I describe as evaluating transformation ideas. And to be able to do that, to be able to think about how I might change a process from as it is today to how it might be in the future, I need to have the ability, I need to have the flexibility in the software, the control over the digital twin to be able to change absolutely anything in the process, the structure of it, any of the numbers going through it, and then to be able to simulate what the impact of those changes is going to be on business metrics, which I care about. So financial metrics, customer satisfaction metrics, ESG metrics even. And so the use cases for that are going to be, we're looking at process transformation, we're looking at process change, we're looking at changing technology, we're looking at an ERP migration, for example, or, and very topically at the moment, we're seeing a lot of using this for automation design. Where are the best places to be targeting my RPA initiatives? Where am I going to get the most bang for my buck as I automate across a process? So I think, like, just to boil this down, there's basically five fundamental requirements that we've identified over the journey that a process simulation platform needs to be able to do to fit what I just talked about on the previous slide. So first up, you're going to need to have a fully flexible and extensible process simulation framework. I say in brackets here, mathematical, not statistical. So this is not some correlation-based analysis of how things have related to one another in the past in the process. This is a real causal description of the dynamics of a business process. Secondly, you want these things to be modular and composable, so we can build them in small pieces, validate them, and then connect them together. Obviously, we need to be able to simulate into the future, so we need to be able to do forward-looking analysis, generate data, so we can think about how a process and its metrics evolve going forwards. Ideally, you'd want access to every single thing at every single time step all the way across the simulation. So you're not just seeing what the metrics look like in 2 years' time, but you're following the evolution of the metrics as they evolve across the lifetime of the simulation horizon. And then I think probably most fundamentally, you need to have control over absolutely everything. So you're going to want to have the flexibility to change the structure in any way and the parameters in any way to reflect the sorts of changes that you want to evaluate in the real world. So with that, I'm going to hand over to Martin, who's just going to drive us through a very simple demo, just to lay the foundations for those who may be new to process simulation, maybe who are new to Silico. We take you through the very fundamentals of what goes on inside Silico before we start to have a look at 2.0 and some of the new stuff that's come out.
Great, thanks, John. So what we're going to have a look at essentially is just build it up step by step of introducing the simulation elements that we have, and that you'll see later when we're introducing the 2.0 features, showing you how they compose a process modularly, extending that sort of digital twin beyond the process itself, and then using that to generate some insights using scenarios and dashboards. So as sort of a very sort of starting point, so what you see here is essentially our studio interface, so where we build processes out, and as John said, it's a sort of graphical but also mathematical framework to build business processes. And there's sort of three core building blocks that normally compose a process. So first one, we want to have a look at our flows, which you can think of as anything that moves through our process. So if we have an order to cash process, this might be new orders per day, for example. And we could obviously develop a very sophisticated volume forecasting module, or we could just say, let's say, you get 10 orders per day coming in every day into your order to cash process. And then the second element we're going to look at are stocks, which you can think of sort of backlogs or queues. And it's sort of fully graphical and then sort of very user-friendly in that we don't really have to do a lot except to say that our new orders coming, and the way where they're going to go is eventually a queue, which is our stock, and we're just connecting these two things graphically. What's happening underneath is, as John said, sort of you can control what's happening and see what's happening at each time step. So we just typed in 10 at the top here, which means, if we simulate our process per day, so we've got the 1st of July, the 2nd, we're getting 10 orders new every day. And because they all just enter a queue and there's nothing being processed just yet, so there's nothing going out of that queue of taking things out of it, what we get here is we start at 0 and then we're getting 10 new orders coming in. They're not being processed, so we just get 10 more orders every day that are just waiting there. And obviously the next step we want to do is create effectively sort of an outflow of things that are being processed. Again, we just connect it graphically. We've got orders processed per day in here. And now what we actually want to do is, build out mathematically what determines how quickly things get processed. So we might have a variable that represents FTEs we have. And we're just going to set that to 1 person. And we might have another variable that is the orders that each of our employees can process per day. And we're going to set that to, let's say, 5. And then we can just connect these two graphically together. And then it sort of triggers us to use them actually in that formula field. And in this case, it's as simple as multiplying these. And usually sort of that's the complexity of the math behind it. It's just that if we do this for lots of steps in the process, it gets more complex, and then you get interesting dynamics between these. In this case, we're getting 10 orders coming in, we're getting 5, we're processing 5 a day. So we've got our backlog accumulates by 5 every day now, because that's the delta between what's coming in and what's going out. And what we can then do is, build in a scenario. So we might want to say, what if we've got a scenario where we've got more FTEs, and let's say we increase that to 2. And then we can see, we've got double the processing capacity here now. So we've got our base case where we've got 1 FTE, where we're processing 5 a day. We've got our red scenario where we're processing 10 a day. And now our backlog also stays at 0 effectively, because we're processing everything that's coming in every day. And these are the 3 core building blocks that we use in any of our simulations. And these then sort of scale up modularly over sort of entire processes. So what you see here is effectively an extension of this order to cash process. We've got new orders coming in, which are set to 100 a day. They go into a review step, getting processed there. Then here we also have a split based on a percentage across orders that we can deliver straight away, and orders that sort of we need to cleaning and we need more information from the customer. And then those also get delivered, and then they're coming out at the end. And each of these, think of these, if there's a sort of an Excel spreadsheet, the analogy here would be this is one of the sheets in your Excel file. So there's more details here, which are, if you double click on it, the same sort of process, just sort of more spelled out with KPIs that we want to use. But essentially, it's the same thing of new things come in, which is the same orders coming in that we had at the higher level of detail. They're waiting in a queue or backlog, they're getting processed, and that processing rate for this step just depends on, again, how many FTEs we have and how long it takes them to process a single case in the end. And that's the same for these other two as well. So we've got the sort of starting, the elemental building blocks, we can compose them to entire processes. And then what we often want to do is actually build on top of that process and extend it beyond just a description of the process with process KPIs like throughput times, but also connected to, let's say, financial models. So what we often see is there's a transformation team working with a process, and there's a finance team of an Excel spreadsheet. And that finance team might, for example, think about, how are these new orders generating cash flow? And what we can do in our sort of simulation platform is extend the process and build in those Excel spreadsheets, transform them into, build them into the digital twin effectively with the same modeling elements. And in this case, it's a very simple example of saying we're delivering orders, they sort of generate a gross profit, and then we accumulate that gross profit for like a final KPI at the end of our simulation. And here we've also got transformation costs, and I'll get back to those later in the demo when we actually use those and change the process. But this is sort of our first step of, we've got the process, we've got it extended now. So now it's sort of decision maker ready. So we could do on a dashboard and we could look at our scenario where we've got more FTEs. Or we could say we'll build in a slider. So for example, we've got our clean order rate split here. We could build that in as a slider and then say, how does our process react if we sort of get less clean orders, there's more issues with orders, how does it react if we get more clean orders that we can deliver straight away, and essentially experiment with how does the process react and how do our KPIs react if sort of the conditions change. And this is sort of, a summary of a baseline of Silico 1.0 of, we've got the simulation elements, they compose modularly to create the process, can extend the process, and then put that into the hands of decision makers with dashboards.
Thanks, Martin. Yes, I think what we just wanted to do very quickly there in that demo was just kind of bring everyone up to speed of when we talk about the fundamentals of process simulation, what's under the hood, what we've been building in Silico 1.0 is all reflected in that demo, and that's obviously a simple example, but it's illustrative of the sorts of things that customers are using Silico for right now. So what I want to turn to in the webinar now, and what we're obviously here for, is to talk a bit more about 2.0. And to frame what we've released in 2.0, I want to just set this out in the scheme of the Silico product vision. So I very much see what we're building at Silico now in three parts. There are three parts to this story. There is, how do you make it quick, easy, intuitive for people to fundamentally build the digital twin? A lot of what was going on in Silico 1.0 was really just about step one. Let's get people to the point where we can actually build these things. Point two then is to actually turn process simulation into a living, breathing digital twin. It needs to be synchronized with data from the real world. So part two of the product strategy then is about being able to have this thing synchronized with enterprise data. And then part three is obviously, once I've got a digital twin, the reason I've built it is to be able to generate new insights, to be able to generate insight about how to change processes, to be able to generate insight about how to better manage processes day to day. So part three of the product strategy is all about delivery of additional insight. So we had the basics, we had steps 1 to 5. And what we've released in 2.0, or at least the headline stuff that I'm going to talk about, is all additive. It all builds on top of those basics. So there are three parts to this. There's one thrust which supports part one of that product strategy about building digital twins. We're doing a lot of work around automatic building of simulations from the outputs from process discovery tools. So we're trying to make it one click to go from process mapping, process mining, task mining to an initial simulation of a business process. So that's part one that we're going to talk through and we're going to show you. Second part is then in line with the second pillar of the product strategy, how do we then synchronize those simulations with enterprise data to create this living, breathing, refreshable, up-to-date digital twin of a business process? And then the last thing that we're going to show you and that we're going to talk about as well is starting to open the box on how do we do optimization once we have a digital twin of a process. So how do we do, see, we can play with them, we can look at them on dashboards, we can change things by hand, but actually how do we computationally do some slightly cleverer things to figure out how to best change a process? And we'll show you that as well. And this is all underpinned. And then the thing that's not very visual that we can't really show you, but that underpins a lot of this is we've done an awful lot of work. Product engineering team's done a lot of work to rebuild the execution framework that Silico sits on top of. So now executes in native code. It also means that this can scale with additional cloud resources. We can scale to support digital twins that connect together many processes. So what we're trying to do, what we've done with the execution framework is remove the limits to the scale of digital twin that is possible to build as we head towards taking our customers on a journey towards a digital twin of their entire organization. So part one, back to the product strategy, let's make it easy for people to build digital twins. So what kept happening to us, what we saw with customers was they were giving us process discovery outputs, process mapping and process mining outputs as the starting point for us manually building digital twins. And we realized quite quickly there was work we could do to automate some of this building. This is really important. It's fundamental to the product strategy. It's fundamental to trying to reduce the time, both to upskill people, but also that time to insights, to try and make it as quick as possible to go from I've done some process discovery, I know what the process looks like, to right now I've got a digital twin of that process and I can use it to drive decision making. So Martin, you're going to hand back over to Martin, who's going to take you through a piece of tooling we've built to automatically ingest BPMN process map files and generate simulations from them. And this is also the underpinnings for how this will work on top of other process discovery technologies.
Right. So the way I want to show you this is essentially a two-step process. So first, we're just going to have a look at the very sort of idealized, simple sort of process that we're going to import, just so we can see sort of what is actually happening, to show you some of the features that it does when it imports these. And then we're going to look at how does this actually scale up if we import like a production-ready, sort of a more realistic process map into Silico. And to give you a bit of sort of the backstory, so when we first discovered process simulation as a use case for our simulation platform, we would get us to set process maps and mining graphs, probably as pictures or screenshots. And then my colleagues and I in the customer success team would use those building blocks that I've shown you earlier and compose the process with the sort of modular steps and link them all together. And as you sort of do that a couple of times, we realize sort of there are rules and there's templates that we can develop and we use as we build these simulation models. And then you're not far off to say, well, if we've got sort of rules and templates we use, then can we not just automate that process, or if someone gives us a BPMN file rather than a picture, and we implement that automatically? And to do this, sort of we got our 3 core simulation elements that are still going to be used, but you don't have to build them manually. And instead, we've got 2 new elements, which are process models and FTE pools. And FTE pools are essentially a way to say, if you've got a lane or a pool on your process map, like a sales team, in an order cache process, and we could, again, drive this with maybe capacity simulation that we sort of use to forecast FTEs in our process. We can set it to, let's say, 5 for now, just to set a fixed value. And then we've got process models, which are where we're actually going to import BPMN files and generate that digital twin automatically. And as soon as we create one, it will ask us to essentially either upload a BPMN file, use an hours connection that we're going to have a look at in a bit, or sort of create a placeholder, an empty one for now, that we can fill with something later. And for now, we're going to upload a BPMN file. It's sort of a drag and drop. You just sort of upload your file here, and then we click continue. And what we now have is sort of a BPMN version of that process. So we've got a start event with new orders. We've got a manual task of checking or reviewing the order. It's the same process we've looked at in the last demo, just in this case, it comes from a BPMN file. We've got a split if there's an order that's unclean. we might read no information from the customer, and then all orders get delivered at the end. And what it does automatically is we've got this process view, which is similar to a process map, but we also have a simulation view where we can inspect of how has it actually translated our process map into a simulation model using the sort of rules and templates, so that we've got new orders that have just sort of that inflow. So the simulation elements are still all there. They're just now generated for you automatically. We've got our check order process, which has the same structure that we've seen earlier of things come in. It's got an automated route here. But if it is sort of processed manually, then again, it depends on how many FTEs do we have and how quickly do they process things in the end. And the way we then set these values is sort of, if you've been in our last webinar, we sort of discussed you need sort of two things to build a digital twin. You need to know the structure of the process, and you need to know the input values. We've got the structure imported now, so all we have to do is setting the input values. And we can just click on it and say, they've got 15 cases a day arriving, so 15 new orders per day. We it asks us to parameterize these different steps. So we might have an automation rate of 80% when we review and check an order. It might take us a quarter of an hour, and it's our sales team who did it. And this is sort of where these shared FTE pools come back in that we've set up before. And then we actually get a different parameterization for this other step, because what we've also built in is that it picks up what kind of activity you've got on your process map, and based on that, implements a different sort of step for that process. So here it's recognized of, if we're waiting for customer information, it's not FTEs that determine how quickly things happen, but rather how quickly sort of customers reply to us on average. So it's asking us here now, how long does it take until a customer normally takes back to you once you've told them there's an issue with your order? And we can just put in, let's say, 5 days until we get a reply on average. And then we've got our final step, which again, it recognizes as internal. So where you might want to say it's not automated, it takes half an hour. And it's also, in this case, our sales team, which is that FTE pool we've set up earlier. And we can again sort of inspect that model and see we've got our 15 here, we've got our 80% automation rate, we've got our quarter of an hours. All these values are put straight away into the right place in that simulation model. But effectively, right, you just import it, you set the numbers, and then that simulation of the process is working as intended, and just like it would be if you've built it by hand, essentially. And then we can repeat the same process that I've shown you earlier, right? We could connect it to, let's say, a financial model. In this case, let's say we've got a revenue variable here, and it's just a matter of connecting the process to it and saying, in the process model, we've got a delivery step. I want to get, how many orders we've actually delivered at the end, and maybe multiplying that with a unit price to have a daily revenue figure. So it's just fits in natively into everything else that we've built already and that we've been using before. So that's sort of the simple part, just to get the idea across. So, you import your file, you set the numbers, and then you use that simulation of the process. And it also scales up across sort of much bigger processes. So if we've got, for example, a purchase to pay process in ours, which we've got here, someone identifies requirement to buy something, creates a purchase requisition, it's get reviews, does a gauge where it's rejected or a purchase order is created. And if I scroll out a bit, you can see it's much more complex than that 3-step process we had earlier. It's got sort of a couple of end events, more branches that sort of nest and come back together at different points. And just as easily, we can say, create that new process model, import from ours in this case, and then it will ask us sort of what exactly do you want to import and where do you want to import it from. So we've got our purchase to pay here, and then it generates that same process. So we've got our requirements identified, create the purchase requisition, review it, and now it's the same process again, clicking on it, setting the right parameter values, and then using that simulation, for example, to drive some financial KPIs.
Fantastic, thanks, Martin. Yeah, so that's kind of part 1 of the 3 things that we wanted to show you out of Silico 2.0. So as you can see, trying to make it much easier, reduce the time to value significantly for customers, get these things built, and a really nice way to be able to mix in existing kind of BPMN information that's sitting around the organization and continue to enrich it with that flexible simulation framework, which we've already talked about, that was there in 1.0. So part 2 of this, the part 2 that we want to show you is then about this synchronization with the real world. So we're going to show you, more correctly, Martin is going to show you something we've built that we call Silico Sync, which is about connecting to data sources, having those connections be refreshable, and then how to wire the data points into the correct parts of the digital twin. So the order number that's coming out of Salesforce wired into the start of the order to cash process.
Well, let's do that. And my Zoom is slightly in my way, apologies. There we go. So we're now sort of in our sync area. What you've seen so far is Studio, which is where we manage sort of digital twin projects and where we actually build dashboards for decision makers. And we are now in Sync, which is sort of a separate area where we've got two things. We've got data integrations here, and we've got data sets. And you've actually seen a data integration being used just now when we've did the hours import. So what we can do here is specify, for example, go to this hours instance, here are the login details, and then that we can use that connection in models to import BPMN files. But we can also create other integrations here, for example, to ERP systems or CRM systems to essentially query those databases and then load that data, refresh it, and load it into models. And I'm going to show you this with the example of just a CSV upload. So we can upload a refreshable sort of CSV file. Just got to get our data here. And then just all we have to specify is effectively, if we have multiple time columns in that data, we just need to specify which one to use. And in this example, why we've got a fair bit of information, we've got two different sort of data points, so how much we've sold and at what average price. We've got here as columns, and we've got sort of specifiers for where we've sold something. So we've got Europe in here, and we've got America further down as two different regions where we're selling, and we've got sort of two products. So we've got bikes and cars in this example, with different volumes and different prices, and both of these change at effectively each day. And all we got to do is, tell the system the time columns and click save. And now that data can be used in any model. So because we've synced separately from Studios, we basically set up integrations and queries once, and then we can use them in multiple projects. What we're going to do here is we've improved sort of functionality of data tables, which we had before, which are basically a way to say, I've got different columns, I've got time steps here, and we always had the functionality to basically fill them with data. So just write numbers in there or copy and paste them from, let's say, spreadsheets in. But what we're going to do instead of doing this manually is say, rather than using a manual set, just go back to that data set I've just created with a CSV file. And all we've got to say is, in this case, I want the sales volume in there. And it will then transform that data into the format that the model is expecting. So if you remember, we had bikes in there and cars in there and different regions in there, and it basically transformed all that into a sort of what time unit our model is running in. So in this case, it's days, but it could have been weeks, and then it aggregates that differently. And in this case, sort of it sums up the sales volumes across all regions and all products. But we could have also said, give me the average, which might be more appropriate if we want to look at the price. And then sort of we can specify, what to do if there are no data points. And I'll come back to this in a second. Sort of we've got data here for essentially January, but no data yet for February. And so far, we just want to use this model. I prefer just a normal stack and flow that you've seen earlier. Just going to connect these, and then we can just effectively use that data in any model. I want to use the sales volume summarized by sum, and I could drive anything in my model with these updated data points. And what we want to have a look at now is, if we've got, fast forward a day, we know I've got data for the 1st of February. So we might have a new version, and instead of uploading a new version, it could also just be a new query over a connected system. We're going to load that in, we're going to save it. And if we go into our data table now, we still got the 1st of Feb as 0. But if we refresh data now, it goes into the system and it pulls that new data out. And it will also do this automatically whenever you go out of the model and back in. So whenever you start the model and look at it, it should have got the most up-to-date information. And similar though, our sort of model parameters here, that was previously just under 8,000, and it's now updated with that new data point. And that's sort of the simple idea of, you set it up once, you can use it in any model, it sort of transforms it into the right format straight away, and you can then drive any simulation with the most up-to-date data. So a typical use case might be, for example, if we have sort of, again, a bigger model, in this case, it's an order to cash process with sort of 3 stages and lots of steps. If you've been in our webinar 2 weeks ago, Dan did a great job of going through this model in more detail, and you can see all the details of it in YouTube and the recording of that webinar. But effectively, it's got a starting point, which is sort of a simulation of future order volumes. and it runs different scenarios, like, for example, different growth rates over it. And what a use case for this is, for example, is we've got a connected system like an ERP or CRM system. We query that rather than uploading a CSV file, and then check the latest order volume. And then we feed that into our sort of volume scenarios, and then effectively use the latest information, apply, for example, growth rates to it or spikes or something that we want to test our process with, and then sort of funnel them for our order to cash process so that decision makers who use this for transformation decisions, they've got the latest information and the scenarios update based on the latest information when they make transformation decisions. Or if they want to change, let's say, capacity, then capacity decisions are also based on the latest information about volumes.
Fantastic. Thanks, Martin. Yep. So that's part two. That's aligned with the second sort of pillar of the product strategy. So how we're handling this idea of having a living, breathing digital twin of a business process connected to refreshable data sources from different parts, different places, different sources across the enterprise. And now we're going to look ahead to the third pillar, about delivery of insight. And so a lot of, in Silico 1.0, the delivery of insight was all done through the dashboarding layer, which you've already briefly seen and certainly would have seen a lot of on the previous webinar. You can think of what people were doing on that dashboard as a form of optimization, right? They were playing with things they have control over in the process, playing with FTE numbers, playing with changing the process in different ways, and looking at the KPIs and metrics they care about, so revenue or cost or customer satisfaction or delivery time or whatever those metrics are. It's a very sort of naive, hand-cranked form of optimization. And what we've worked on, what we saw repeatedly was an opportunity to actually do some cleverer, out-of-the-box computational optimization over a digital twin of a business process. So what Martin is about to show you is part one of our optimization story.
Right. So if you remember that very simple sort of process that I've showed you at the beginning, you might have already noticed some of these looks just ever so slightly different than the other ones. Essentially, right, these are process steps that are sort of modular. And if it's modular, then obviously we might want to experiment with changing that module. So if we've got our order to cash process here, and all I've done as sort of a first KPI to show you something is effectively go in each of these steps and just look at how big is the queue, or how big is the backlog, and how is that changing over time. So you've got a graph here where we've ended up with about 8,000 things backlogged at the end of our simulation. So we're getting 100 orders in, but we're only really delivering about 60 a day. So people might then say, okay, how can we fix that? How can we make the process more efficient? And someone might have ideas about changing how we deliver orders and get them out the door to the customer. Someone else might have sort of ideas about what if we change the review. And what we want to do is play with these different ideas and identify the best ones. And for that, we've built in what we call process variants, which are effectively sort of modular changes to these different steps. I'm going to show you three things. Firstly, we can change a value. So like I said, right, in the end, how quickly things get processed might depend on effectively FTEs and how long do tasks take. And if it currently takes us an hour to sort of get an order to the customer, what if someone has an idea to essentially lower that to 0.6? So that number at the top has sort of now changed. So we can change values when we sort of switch these different variants. And interesting, right? It's not just one value. It could be any of the values on here. And one thing we've added is that this change might cost us, for example, £50,000 to implement. At the same time, we can then, what effectively happens when we change these is, so as I said before, you've got about 8,000 cases backlogged at the end of our simulation here. And if we change that, you can see sort of that part of the simulation effectively gets replaced with that updated or alternative module that we specified here. So as we sort of switch these through, we can see that changes from the as is to our to be process or potential to be process, and our KPIs here all update. We're now delivering just under 90 orders a day, which is still not quite 100, but we're sort of getting there. And we can then do the same thing at a different point in the process. So I've shown you a change in value. Like I said, sort of at the moment, this is just things come into the step, they queue and wait until someone processes them manually. But what if someone wants to play with adding things to this process step, sort of building it out more? For example, sort of the easiest way to get the point across by adding an automated route. So in this case, we've still got 100 coming in, but then they get split into 50% automated. down here and 50% manual down here, and then they come back together to leave this step at the end. And here, in this case, we've added essentially a route through this process step. Or it could also be, if we want to remove things and say we fully automated, and now a lot of these variables that you've just seen disappeared, and it's just things come in and things just automatically flow out again. And what I've just shown you is effectively why we can change values, and we can change multiple values at the same time. We can add things, we can delete things. So you can change these modular steps in any way you want. So you can really implement and then simulate your process ideas virtually before you then do that in the real world to effectively see what the impact of these different changes would be. And as I said at the beginning, we've got transformation costs here, right? And as I said, the 2V, for example, will cost us 50,000. If we change the review step, it will also cost us something. And we could also play around with this on a dashboard where we have our profit before transformation costs. And if we are just in the as is process, then obviously that's the same as profit after transformation costs because we're not changing anything. We've got sort of our 8,000 cases backlogged here. And we can now play around with, okay, what is actually the best outcome? And maybe we want to optimize profit after transformation costs. Again, play around with these different combinations to figure out, in what case is that highest. But obviously, right, as this scales up and you get more and more steps that you might want to change and more alternatives, ways in which you can change each step, you've got to go through quite a few combinations here. So we've built an optimizer where all we have to do is specify what we want to optimize for. So in this case, our profit after transformation costs, we're doing that for a base case. But if we had other scenarios, we could also just say, optimize for this growth scenario where we're getting more orders over time, for example. And then we just want to compare this to the as-is process. We just hit optimize, and then it will find us the best sort of combination that's telling us, don't automate this fully, automate it to 50%, which probably means, right, there's a benefit of automating more, but not in excess of the cost it will produce to actually implement that full automation, and sort of lower the processing time here, which is the first thing I've showed you with changing the variables. And then we can close that window and can sort of observe sort of what the difference in backlogs is, what the profit is, what the difference in costs is, and then what the actual benefit is. And we can use that to make a business case to our stakeholders and basically say, we've tried all these different combinations. This is the best one, and we've got an objective and quantitative measure of why we should be implementing this transformation. And then just to sort of round it up, if we go back into our bigger process where we've talked about the data input as well, there's also scales up across more sophisticated processes where we might want to automate or play around with different things to confirm orders at the beginning of the process, or generate delivery documents, or send invoices, where we can do the same thing and effectively say, if we've got a process and it's as is and might be fine now, but for example, if we grow order volume, you see lead time goes up, customer satisfaction goes down, lots of things get stuck with, in this case, the first team. We can play around with this and see what the impact of different changes would be and how they might, for example, in this case, push backlogs and queues to the next team. And we can also go into the optimizer. We want to compare again to the as is. We hit optimize, and in this case, what I've done is we're sort of optimizing for profit again, but it could be any other variable. We're sort of optimizing for actually a growth scenario rather than just a base case where everything is fine. And then it goes through all the possible combinations, about 40 in this example, and it tells us here how to best automate the process with sort of a 9% additional profit and payoff. And with that, run back to you.
Thanks, Martin. Yeah, so that is the end of the demo section. We're basically at time. I've got one more slide that I just want to talk about very briefly, which is just a very quick word about where we're going next in terms of the Silico product vision and the work we're just starting now to put the foundations in place for Silico 3.0. And I think you can, the very short summary of this is, this third pillar of the product strategy about delivering insight is the one where a lot of our focus is right now. You can see in the optimization, with computational optimization, you can start to deliver some really interesting things where the human analysis to evaluate that many possible transformation initiatives would be prohibitively time consuming and prohibitively expensive. We can do it at the click of a button now. We're working on some more interesting things, leveraging some newer technologies, some technologies from AI, particularly generative AI, and using those to start to guide sort of more nuanced ideas, generating actually ideas for where you might want to change those processes. So I'm hoping that we'll be able to share something this year, at least an update on where that's coming and what to expect. So, please stay tuned to our webinars, particularly our product webinars, if that's something you think is interesting. And with that, we're out of time. So I'm afraid I don't have time to take any Q&A. We will, however, anyone who's put a question in the chat, we will get you a written response. We'll come back to you and answer those questions. I think we'll also share our answers to all of the questions that are asked throughout the webinar in a follow-up email. And if anyone wants to watch this again or wants to share it with a colleague or someone who couldn't see it online in real time, it will be on our YouTube channel shortly as well. So you can go there and watch it and pause and look more closely at all the things Martin has demoed for you. All right. Thank you, everybody.
Thank you.